Congruence modulo M. Okay, let's look at this relation. Let M be a fixed number, a integer. Now, two integers A and B are said to be congruence modulo M if A minus B is divisible by M. Okay, and the way we write it is A is congruent to B mod M implies and is implied by M divides A minus B. We should put the bracket because otherwise M would divide only A and then minus B. So that would be a wrong interpretation. Okay, let's look at some examples. 18 is congruent to 3 mod 5, which basically says that 5 divides 18 minus 3, which implies 5 divides 15. Right? Whereas 25 is congruent to 2 mod 4. Now, here what would it mean? 4 divides 25 minus 2. 4 divides 23, which is not the case. So, this is not congruent. So, relation congruence modulo M on the set Z, that is integers, is an equivalence relation. Okay, remember reflexivity, symmetry, and transitivity. Okay, so let's look at each one of this. Reflexivity basically means let A be an integer, then A minus A, or let me take it step by step. We could say A is congruent to A mod M, which means what? Which means M divides A minus A, which implies M divides 0, right? So we can say that A is congruent to A mod M for all A belonging to the set of integers. Okay, that is reflexivity. Now let's look at symmetry. Now let's take two numbers A comma B belonging to the set of integers such that A is congruent to B mod M, which implies M divides A minus B, right? Now, which implies that A minus B is equal to some multiple of M, where lambda belongs to the set of integers. This implies B minus A is equal to minus lambda M. We took out minus out and we took it to this side, or multiplied both sides by minus 1. So which implies B minus A is a multiple of M. So which implies B is congruent to A mod M. So what did we do? We said A is congruent to B mod M and B is congruent to A mod M. So which means this relation is symmetric. Now let's look at transitivity. Okay, now let's take three numbers. Let A, B and C belong to a set of integers such that A is congruent to B mod M and B is congruent to C mod M. Now this implies A minus B is a multiple of M, which implies A minus B is equal to, say, lambda 1 M. Okay, similarly with respect to B is congruent to C, we can say B minus C is a multiple of M, which implies B minus C is equal to lambda 2 M. Right? Now here lambda 1 is an integer and lambda 2 is an integer. Okay, now let's add these two, this one and this one. What do we get? A minus B plus B minus C is equal to lambda 1m plus lambda 2m. Now, if we open up these brackets, B and B gets cancelled and we are left with A minus C is equal to m is common. So lambda 1 plus lambda 2. So we can say A minus C is equal to lambda m, where lambda is equal to lambda 1 plus lambda 2. This implies that A is congruent to C mod m. So, which means, based on all these three, we can say that congruence modulo m on Z is an equivalence relation. Okay, so that is congruence modulo m. That's it for now. Bye.